All right, 5.1, vertex form and transformations. So in this video, I'm going to show you how to graph using vertex form, how to write an equation if you're given information with like transformations, things like that. We're going to find minimums, maximums, axis of symmetry, all kinds of good stuff. So let's jump right into it. So it says a quadratic function is a function whose largest exponent is degree 2. We learned about the parent function in chapter 1. The graph is a U-shaped curve called a parabola. So here's what the function looks like. It's f of x equals x squared. So when I said degree 2, that's that 2 we're talking about. And let's just make a little table to refresh ourselves what it looks like. Remember, f of x is really the same thing as y. So if I make a little xy table, and we'll start with 0. When I plug 0 in there, I get 0. And when we plug 1 in for x, 1 squared is 1. And when I plug 2 in, 2 squared is 4. Over 2 up 4. And 3 squared would be 9. And we're very quickly going to fly off our graph. Now the interesting thing about the quadratic parent function here is when you go in the negative direction, you know, if I put a negative 1 in and square it, a negative 1 squared, you just get 1 again. So right there would be a point. When I put negative 2 in, negative 2 times itself is also a positive 4. And you get this symmetrical looking curve that pretty much climbs up the other side just the exact same way. So when you smooth this thing out, you have this, I guess not totally a U, but kind of like a U. Opens up. That's called concavity. It's concave up. And it kind of looks like a bowl like that. So a couple things I really want to kind of harp on here that is very important for me, how I graph it, is that relationship between when you start with your vertex, just kind of put a V there, going over 1, up 1, like that's important. Going over 2, up 4, and then going over 3, up 9. That pattern, I really want to burn that into your head, because when we start doing stretches and shrinks and compressing things, we're going to be changing this number right here. We're going to be messing with these vertical numbers. So I really want you to kind of focus on that. So some other things that we're going to talk about that we can get from this problem is, well, for this problem I can see where the vertex is. So that's something that's going to be important on all these questions. I'm going to ask you where the vertex is, because it's going to move. 0, 0. This thing is concave up. Concave up. And in general, that's referred to as concavity, saying whether it's up or down. Opens up, you could also say. Another thing is an axis of symmetry. Axis of symmetry, meaning that there is a fold line where you can fold this thing on top of itself, and for this one it would be symmetrical right here, right along this y-axis for this problem, which if I were to write an equation for that, the axis of symmetry is at x equals 0 for this problem. So that's the fold line. Then the other thing we want to know is we usually want to know, do we have a minimum or a maximum? And this function has a minimum. This function has a lowest value, and the minimum for this one would equal 0, meaning there's no y values that go below 0 on this graph. So these are all kind of 4 points after we graph it that we need to know the key features that are sometimes tested on the SAT. All right. First example here, this is kind of a review from absolute value when we were graphing absolute value and we were, reflecting it over the axes and we were moving it left and right and up or down and shrinking it. Same idea here. So remember, this back number, if it's positive, this is telling me that it's going to get shifted up 2. In the parentheses, it's opposite of what you would think. So since it's a -3, it's really going to be going to the right 3 units. So my vertex is going to go 3 to the right, 2 up, which is going to put me right here. And now I'm going to play that same game, though. Over 1, up 1 in both directions. Over 2, up 4 in both directions. And then over 3, up 9, which is actually going to go off the graph in both directions. And then you can very quickly sketch a nice little parabola real quick without using a table, without using a graphing calculator. You just have a nice little quick look at it. And that's kind of where this thing gets its name. You know, this is in vertex form. Just like there's slope-intercept form, there's standard form. Well, there's vertex form because I can look at it, and as long as it's a minus sign in parentheses, I can see that there's the vertex. It's at 3, 2. The tricky part is that parentheses 1 is opposite from what you would think. So let's kind of talk about some important features for this one. So one important feature is, you know, let's label the vertex. The vertex is at right 3, up 2. This thing is concave up because it's opening up. We do have an axis of symmetry line. I'm just going to abbreviate this. Axis of symmetry line is going to be right here, which cuts through at x equals 3. So that's the axis of symmetry. And then we also need to know, does it have a minimum or a maximum? Well, this one has a minimum right there at the vertex, and it looks like it has a minimum at 2. It doesn't go below 2 ever. It goes forever in the up direction, but 2 is like the bare bottom. This one over here on the right, let's kind of look. I think there's 3 things going on. So when I look inside the parentheses and it's plus 2, I know that we need to go left 2. This minus 5, this is going to be down 5. And then I also remember you got this negative sign in the front, which is going to flip it. Or, you know, I should say it's going to reflect over the x-axis. All right? So it's going to open down. So let's kind of do this. So our parent function, it's going to shift 2 to the left, down 5, which would be right here. And then since it's reflected, it's actually going to flip down. It's going to open down. But I'm still playing the game. I'm still playing the 1 to 1, over 2, down 4, over 2, down 4. And I don't have to do the 3 part because I'm going to go way off the graph. So a lot of times, really 5 points is probably enough. I just sometimes, if I can fit them on the graph, I'll do the extra mile and go a little bit further. So let's answer some questions. So this thing has a vertex at -2, -5. So remember, it's always opposite, same. It is concave down because it opens down. We have an axis of symmetry. Some books just say AOS for axis of symmetry. If you want to do that, that's fine. Axis of symmetry would be at x equals -2. And then this graph is going to have a maximum because it has a highest value. And it looks like right there is going to be the highest value at -5. Notice the max and the min should always match up with the y value on your vertex because that's the highest or the lowest point. So just kind of something when you're doing a quiz or a test, you should always kind of double check that. All right, we'll do a couple more here. So on this one, we got a new something going on here. So I look in the parentheses. I'm like, all right, +1, it's opposite of what I would think. So we're going left 1. -2 means we're going to go down 2. So that's my vertex. All right, so I'm going to go left 1, down 2. Now, this number in the front, that's going to stretch it. All right, that's going to stretch my y value. So it's going to be kind of skinny. it's going to be a skinny parabola. And I'll show you what I mean. So instead of playing the game where we go, over 1 up 1, we're stretching it by a factor of 2. So really I'm going to go over 1 up 2. So we go over 1 up 2 this time, over 1 up 2. Well, normally we would go over 2 up 4, but now we're going to go over 2, and we're going to double that. We're going to have double the stretch going up. So it's going to be a 2, 8. So over 2 up 8 takes me to right here. Over 2 up 8 takes me to right here. And you'll notice that we have this parabola that's really skinny. All right. It didn't flip over. It wasn't a negative. So this is just a skinny one. So I'm going to answer some questions here. If we would have went 3, instead of going 9, it would have went up 18. But we're flying off the graph, so don't worry about that. So let's answer our questions. Vertex is at -1, -2. Remember, it's opposite, same. This is concave up. This has an axis of symmetry at x equals -1. And also, that axis of symmetry should match this part. Just like this problem has a minimum at y equals a y value of -2, which should also match that part. So your axis of symmetry and your minimum actually should match. So that's kind of a nice little way to help you out. So let's go over and let's do this next one. So over here, we have something kind of new going on. So I'm going to erase what's on the left. So this one I noticed that there is no back number. I'm like, what the? There's nothing there. So all you got to do is pretend that's a 0. So we're not moving up or down. So for this one, the only thing I have to do is a -3 is going to put me right 3. So as far as the vertex goes, just shift right 3. So there's my vertex. Now, it's not a negative sign, so I'm going to open it up. But now we have this half in here. All right? So this half is going to actually compress it. Or, I guess I'm going to body shame it. It kind of makes it fat. The other one was skinny. This one's going to kind of make it fat. So what's going to happen is, let's do the normal. The normal parent is 1, 1, 2, 4, 3, 9. That's the normal one. Well, we're going to shrink it. We're going to shrink that height and make it fat. So instead of going over 1, it's going to go over 1 up a half. Or it's going to go over 2, but it's only going to go halfway. It's going to be 2. I don't like that 2, so I got to rewrite it. And going over 3, instead of going up 9, we're only going up half a 9. We're going up 4.5. So that's kind of what's going to play out on this one. So from this point, I go over 1 up a half, over 1 up a half, over 2, instead of going up 4, I go up halfway, and go over 3. I'm going to go up 4.5, and 3 up 4.5. And if I wanted to keep going, normally I would go 4 squared is 16, but here I'm going to go 4 over and half of that. So I'm going to go over 4 up 8, which, when you make them fat like this, you can actually fit them on the graph a little bit easier. So now I have this kind of fatter parabola coming down. It kind of looks something like that. So it just kind of smushes it down a little bit, makes it open up a little bit wider. So let's list out our stuff. So our vertex moved 3 to the right, didn't move up or down. We have, it's concave up. Concave. Axis of symmetry, is right here at x equals 3. Matches, so we're good. And so that's AOS. And then this is also going to have a minimum at 0, which matches the y like it's supposed to. All right. So those are some examples of how to graph these. In general, I don't know how much it's going to help, but in general, vertex form, just so I kind of lay it out to you. To me, it's more important to just know what it does. But somewhere in general, here's what it looks like. It's y equals a x minus h squared plus k. And basically, hk is the vertex. And then the a kind of tells you whether it's going to, it's a scale factor. It's going to tell you whether it's going to stretch or shrink. So a can tell you, is it going to stretch or is it going to compress? Which you stretch when a is bigger than 1. You compress when a is less than 1. And then also, it opens up when a is positive, and it opens down when a is negative. All right? So that's kind of all the things that can happen inside that little vertex form. I just think it's easier to give you examples first before you get all formal with the letters. At least I find it that way. All right, last couple examples. And there are some tougher questions on the homework from the SAT. There's always some of those. So this one says, write your own equation in vertex form, given a description. So just somebody telling me in words. So they're saying that the parent function is reflected across the x-axis. All right, so if you reflects across the x-axis, that tells me that, well, actually, I'm going to put this in black. F of x equals, well, that blue clue right there tells me it's going to be a negative because we're reflected. Then we vertically stretched by a factor of 5. So stretch factor is going to go here. Then we translated 2 to the right. So in parentheses, we'll do this in green, 2 to the right. So 2 to the right means I have a minus 2. And then the 3 units down, I guess I'll go back to blue for this one. I'm running out of colors. 3 units down means I'm going to have a minus 3 at the end. So there's a way to kind of describe everything that happened. Right 2, down 3, flip it, and stretch it by 5, which that would be a monster stretch. You know, normally if you're going to go, 1, 1, over 1, down 1, on this one you're going to go over 1, down 5. It gets magnified. Normally you go over 2, down 4. Well, this one's going to go over 2, down 5 times that amount. So it would fly off your graph extremely quick. So you won't see me have too many where that front number is really bigger than 3. Otherwise, you just run out of real estate too quick. All right, next one. Quadratic parent function is vertically compressed by a factor of 1/3. So I know when I write this thing out, maybe I'll call this one g of x. Doesn't really matter. Just using function notation. So it didn't reflect it, so it's going to be a positive 1/3. And we're going 4 to the left. So 4 to the left, well, that is plus 4, because it's opposite of what I would normally think it is. And then we need to go, and I just noticed that I totally forgot my power on this last one. Got to put my power in there, otherwise we just have a line. And 1 unit up. So the 1 unit up is going to be the plus 1 at the back. So make sure you don't forget that little squared symbol like I did. All right, hopefully this is enough to get you a good head start and get you rolling on the practice. See you.